Okay, just a couple more of these trinomials. So no GCF with this one. I see 2, but 2 doesn't go into 5. So it's good to try to think through the GCF. We're still going to do the same process. A times C here, 2 times 3 is 6. Everything is positive. So I need two numbers that multiply to 6 and add to 5. So my 6 factor tree is tricky, but it's short. 1 times 6 and 2 times 3. There's my factor tree. And now I need to figure out which one of those combinations adds to 5. Now we could subtract to 5 with 1 and 6, but since everything is positive, we're going to use 2 plus 3 to give us that 5. So we're going to change our middle term, just like we have with every other problem, to 2x plus 3x. We're going to bring down our 2x squared and our 3. Now this problem and the next are a little different because with our first two terms, we're not going to just take out an x. They definitely have an x in common. But if you look at the two terms, they also have a number in common. They have that 2 in common. So here we're going to have a GCF of 2x to divide out. 2x squared divided by x, all I'm left with there is a single x. 2x divided by x is really tempting to write 0 here, but you need a placeholder. 2x divided by x is 1. We're always going to bring down that middle plus or minus. And then 3x and 3 both have 3 in common. Again, 3 divided by 3 is 1. You have to have that placeholder that's 1. And now we're going to write out our final answer. 2x plus 3 in one set of parentheses, and x minus 1, or x plus 1 in your other. Hopefully you're feeling more confident. This is a process that we've done a lot. There's really no shortcut, just gotta trudge through it. Okay, on to the next. 3, 17, and 10 do not have a GCF, so I'm going to do A times C. 3 times 10 is 30. I need two numbers that multiply to 30 and add to negative 17. So since I have that negative going on, I know I'm going to need some negatives somewhere. To multiply to a positive 30, I'm going to need 2 negatives. So I'm going to keep that in mind as I'm making my factor tree. So 30 is 1 times 30, 2 times 15, 3 times 10, 4 does not go into 30 evenly, 5 goes in 6 times, and that's my factor tree. So now I'm looking to add to negative 17. And since I'm multiplying to a positive, that could be 2 positives or 2 negatives. So let's just add our negatives in there. You may be able to see it really quickly. If you can't, start subtracting. Negative 2 minus 15 is negative 17. Negative 3 minus 10 is negative 13. So if you were thinking of that one, you were very close. But our middle term, our negative 17, we're going to split into negative 2m minus 15m. We're just using m's here because there are m's in the problem. All right, I'm going to erase a little bit of this factor tree. Not that it's not good work, it's just kind of running into our problem here. And now we're going to cut this in half in GCF. So this time we have more numbers going on in the first two, but we still only have an m in common. 3 and 2 don't have any numbers in common. So I'm going to GCF out an m. 3m squared divided by m is just 3m. 2m divided by m is just negative 2. All right, we bring down that middle sign. 10 and 15 have 5 in common. So I'm going to pull out a negative 5. I'm going to be really careful when I'm dividing here. It's going to look a little different than our other problems, but it works the same. Negative 15 divided by 5 is positive 3, and it has an m. 10 divided by negative 5 is negative 2. So this problem had the exact same steps as the last problem and the problem before it. Sometimes it feels a little more difficult because of the additional negatives. M minus 5 is one of our sets of parentheses. And 3m minus 2 is the other. That order does not matter. Again, you can graph the original and your answer and make sure they lay right up